All right, so a frequency distribution that lists all possible data items can be quite cumbersome when there are many such items. So for example, below here we have, consider the following data items. There's 40 students, and these are their test scores. And so listing them all out here, that is pretty cumbersome. It really doesn't tell us anything. There's not in any specific order or anything like that. So it's hard to tell how well the group did just looking at it like this. And because there's so many data items, one way to organize this data is to look in it into classes or groups. And so maybe, if you think about how your A's and B's and C's are, so like over here, A's, that would probably, if you put it 90 to 100, B's would be 80 to 89, C's would be 70 to 79, D's, would be 60 to 69, and then it'd be everything below would be an F. So that would be maybe one way to look at this. Okay, so like I said here, most grading systems assign 90 to 100 as an A, B is 80 to 89. And then looking at the 40 statistics test scores, then we can see they range from a low of 43 to a high of 94. So you just had to go through them all and see what those were. And so what we are going to do is we're going to use classes that basically start at 40 and then go to 49 and 50 to 59, 60 to 69, on up through 99, because again, 94 is our highest, so we'll do that. And the way we're doing this is grouping it into classes. This is called grouped frequency distribution. And once we group them, what we can do is we just have to do our group or our class, find the frequency of each of them, and make sure, again, the total is going to be 40. And so what we've basically gone and done is we've said, okay, how many 80s are there? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. And so hopefully there's 980s. And you do the same thing going through all of those from the lowest to the highest class. Okay. Now, the leftmost number in each class of a group frequency distribution is called the lower class limit. So in this case, what the lower class limit is are the ones here on the left. So, this one, this one, this one, this one, this one, and this one. And then the rightmost one is going to be the upper class limit. So we'll just kind of put a box around all those. So those are all the upper class limits. Okay. And so now what we're going to do is we're going to look at the difference between any two consecutive lower class limits. We are going to get the same number. So 40 to 50, 10. 60 to 70 is 10. 80 to 90 is 10. So no matter what we do, it's all by 10. Okay. And so that's kind of a key thing, is how it is split up there. So that's called a class width. So the width of each of the classes is 10. Now, when setting up class limits, each class, with the possible exception of the first or the last, sometimes those are different. And a key one here would be thinking about the Fs. Fs are going to go from 0 to 59. So there's going to be a huge last class, whereas, and the top class is going to be from 90 to 100. So that doesn't fit the rest of the classes, which are going to be like, 80 to 89. So, that's the number here, whereas that's a little bit bigger and that's a lot bigger. So there's going to be some differences in widths, but on some of them, but not all of them. So you want to try to get them to be the same width. And because each data item must fall into exactly one class, it's sometimes helpful to vary the width of the first or last class. And that's why we have different things here, and that's why it's that way. All right, so now what we have to do is we have to take our 37 exam scores here, and they want us to make a frequency distribution for those exams. So what are we going to do? Well, if we look here, what is our scores? Well, it looks like we have a 41 is a low, and I don't know, I see a 98 off the top of my, oh, there's a 99. So it looks like it's going to be like normal scores. So let's do classes. So the class and our frequency. So class again, if we have a 41, let's go to 40 to 49, then 50 to 59, then 60 to 69, 70 to 79, 80 to 89, and 90 to 99. In this case, we're just going to go to 99 because that's our highest class, or our highest number. And again, if we think about the width is 10. Okay, so it fits with the that for each of them. So if we look either the upper limits, they're all 10, or all the lower limits, they're all 10. Okay. So now we need to find out how many are in this one. Well, we already said we only saw one that was in a 40, so that's that one. So now let's go to the 50s. So now we have, well, okay, let's change colors. That's how we're going to do it this time. So 50, we have 1, 2, 3, 4, 5. All right, so it looks like there's 5 of those. So we'll say 5 of that one. Now let's go to orange, I guess. So 60s. All right, so we have 1 and 2, 3, 4. So it looks like we have 4 of those. All right, so let's go blue now. So 70s, we have 1, 2, 3, 4, and 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of those. So quite a few of those. Okay. Let's go to green now. So 80s. All right, so we have 1, 2, 3, 4, and any more do I see? 5. I think there's just 5 of those. And let's go another color. I don't know what's a good one here. We can do black, I guess. All right, so 90. So now we have 1, 2, 3, 4, 5, 6, 7. All right, so we have 7. So that gives us a total of what? Well, there's that, and that's 20, and then that, and that's, or yeah, it's another 10, so that's 30, and then 7. So it looks like N is 37, which is what we're supposed to get. And so that would be our frequency distribution that's grouped by, 40 to 49, 50 to 59, 60 to 69. Okay. All right, so let's stop there and we'll come back for some more.